To our resource person, Dr. Suvodeep Mazumdar, FHEA lecturer in data analytics, University of Sheffield, our principal, Dr. P. Devasundari, our faculties, and to all our blooming students, welcome all. A school is a building with 4 walls, with tomorrow inside, says Lon Waters. Standing by our founder and chairman, Dr. KCG Verghese' vision to make every man a success and no man a failure, KCG College of Technology is committed in the holistic development of every student, nurturing the attributes of service and ethical value system in technical education, thereby producing responsible citizens and progressive leaders. The Department of Research has come up with trends in data science and Urbanmapper to nurture students with indispensable thoughts. Data science, a concept to unify statistics, data analysis, informatics, and the related methods in order to understand and analyze actual phenomena with data. It is high in demand, and its importance brings together the domain expertise from programming, mathematics, and statistics and makes sense of data. May I now invite Dr. Deepa Jose, Head Research and Associate Professor of Electronics and Communication Department, to welcome the gathering and introduce the speaker of the day.
Welcome to all the participants to this session to International Research Webinar Series on data science. The aim of this series is to have a collaboration with the international universities as far as research is concerned. Already KCG College of Technology is doing collaborative publications with many foreign universities and has also applied a lot of funded proposals, including the Newton-Baba proposal. With these few words, I welcome all the participants once again. I hope all of you make use of this opportunity to improve your research. Let me welcome today's speaker, Dr. Suvodeep Mazumdar. Sir has completed his MSc in Advanced Computer Science at the University of Sheffield. And Sir has worked in the Department of Computer Science as a researcher in the area of human-computer interaction, data visualization, and user interface development. And subsequently, Sir has pursued and completed his PhD under the areas of interactive visualizations and user-centered design techniques. Sir has also worked in the Center for Assistive Technology and Connected Healthcare as a research scientist and as a postdoctoral researcher to continue his research on large-scale data analytics. Subsequently, Sir has joined the Information School in the University of Sheffield as a lecturer, starting from 2018 till now. Sir has applied his research in a wide range of application domains, such as aerospace engineering, sports informatics, crisis energy, emergency crisis management, smart cities, and mobility planning. Sir has worked in several large research and industrial projects funded by the European Union, Innovative UK, and the European Space Agency. Dr. Suvodeep Mazumdar served as a program committee member and a reviewer of several conferences and journals. To name a few, the ISWC International Semantic Web Conference, the Semantic Web Journal, the International Conference on Information Systems for Crisis Management, the Conference on Human Factors in Computing Systems, and so on. Sir has also organized a series of tutorials on visual analytics with social media for crisis management at the International Conference on Information Systems for Crisis Response and ESWC Extended Semantic Web Conferences over several years. So we are very privileged and lucky to have you amongst us here. And over to you, sir, to share the research insights to the participants, the faculty, and the students. Once again, on behalf of the college and the faculty, we welcome you to this session.
Thank you very much, Dr. Deepa, and it's great to have everyone here. I hope you can hear me, and I have a few slides that I'd like to share. So just bear with me a moment while I share my slides. Okay, I hope you can see my slides, and if you have any issues hearing what I'm saying, please do let us know.
Yes, so the audio is audible and the slides are also visible, sir. Yes.
That's great. Thank you, Dr. Deepa. So as mentioned earlier, I will be talking a bit about the trends in data science and a short project called Urbanmapper, and I'll be sharing some of the ideas that we have in the project. So I am in the University of Sheffield, as mentioned, and I'm a lecturer in data analytics at the Information School. And my research is on big data analytics, human-computer interaction, data visualization, crowdsourcing, and citizen science. And I also work on several domains, but it's generally around the developing novel ideas and approaches to support decision-making processes. So essentially, I work with complex data, and I try to, and complex heterogeneous data sets. So large-scale data of different aspects, and I try to develop techniques that help stakeholders understand the data better. And these techniques are techniques like data visualization, big data analytics, and human-computer interaction. And I'm also quite interested working with citizens and user communities. So I use techniques like crowdsourcing and citizen science. So in this presentation, I'll talk about a few ideas around how we can use some of these techniques in the project called Urbanmapper. But before that, I'll talk a bit around data science and where we are at right now. I'll start off with a bit of a background so I can give a flavor for where I'm coming from and my journey so far. So I did my undergraduate, which was BTech in Electronics and Communications Engineering in Kolkata. And then I joined Cognizant Technology Solutions as a programmer. I worked there for a bit, and then I started my master's in advanced computer science in the University of Sheffield. I was a research assistant, then did my PhD, and then did postdoc for a few years, and then I became a lecturer in a different university, and now I am a lecturer in the Information School. So if you look at my background, I am currently a computer and information scientist. So I look at computational aspects, but also I'm quite interested in the information aspects and the social context around the use of information. So where I am currently now is the Information School in the University of Sheffield. And we are quite proud that we are the #1 in the world for information, for library and information management, as per QS rankings by subject. We do world-class research. We are organized as the leading school of our kind in the UK, and we are also part of the iSchools network, and we were the first iSchool in the UK to join this network. We are currently ranked the first for research environment in the UK, and this is on the basis of REF 2014, which is an evaluation of all the research universities in the UK. And the Information School does multidisciplinary research. So our focus is multidisciplinary, and we have different research groups. For example, chemoinformatics, digital societies, health informatics, information retrieval, information knowledge and innovation management, information systems, libraries, and information society. So we have quite a lot of expertise from different domains, and all of us work together in teaching as well as in research. So that's a picture of of the department. This is the department on the right, and there is a quite nice area in front. And in the department, we look at researching 3 different aspects. So in information, technology, and people. And we are often at the middle ground where we try and understand the impact of technology, information, and access to information, and how people work with information. So we look at different aspects of this whole structure. So I always like to do this kind of presentation, a very quick glimpse of where we are in Sheffield. So Sheffield is quite a big city, but it has kind of like a small town center. So it's quite nice as a city to live in. So this is a view of the train station down below, and the city is the cityscape is in front of the train station. So we are looking at Sheffield from the hill. This is how the town center looks like. In front is the big building, which is the town hall. And we have fairs from time to time. And this is in the same area, we have something like an evening fair over there. And this is a picture of some of the standard kind of houses that you come across, the houses and the roads. And I'm showing this because we are going to talk about urban planning. We are going to talk about how we can understand where people live, how they interact with their environment. So I thought it would be a good idea to show how a street, a regular street would look like. And in front, you see a few garbage bins, you see a bus stop, and so on. But Sheffield is not only about the concrete buildings or the landscapes, but it's also about natural scenery. So right outside Sheffield, we have this area called the Peak District, where we can go and hike, and it's really beautiful. So if you do come to Sheffield, I would really recommend you go for hiking in Peak District. But anyway, so coming to today's session, we've done a bit of an introduction, who I am, where we are, and what kind of place Sheffield is. We are now going to talk a bit about big data, where we are now, and a few trends that I thought would be interesting for this topic today. And in this, I will talk a bit about the importance of the social aspects of data science. We will look at smart cities, urban planning, and the project called Urbanmapper. And we will have a quick, very short activity, and I'd like to have some ideas from you and some feedback on some of the things we are thinking of. We will also talk a bit about the role of data scientists and what is our vision of data science in Sheffield. And I will also talk a bit about the information school and about our programs. So before I start, I'd like you to think a bit around this question. So have you ever collected high quality digital data to record the environment, people around you, or yourself? So you don't have to answer this question, but I'd like you to think about this a bit. And what I'd like you to think about is the question of high quality digital data. And if you had thought that, no, I haven't actually done that, I'd like you to think again, because we are constantly collecting data, we are constantly recording data. We are recording data, we are sensing our environments through different mechanisms. For example, smartwatches, smartphones, social media. And we are also contributing to data sets a lot. We use these kind of checking mechanisms called CAPTCHA. We enter data, we select images, and all of this is used to train machine learning models and to train automated systems to do their jobs better. So we are constantly generating data, and this data is constantly used to improve decision-making processes and to improve different services provided. So speaking of data, our world is increasingly digitized. We observe our environments. We capture data about environments and weather. We have sensors, we have temperature sensors, rainfall sensors, pressure sensors, and these are positioned at different locations in cities. So we know how our environment is changing. We know how it is outside, and so on. As we interact with environments, we also capture them and we share how we feel. We constantly post on social media, on Twitter, Facebook, Instagram, about having the coffee or about studying with friends and so on. So we constantly share our feelings as we interact with the environments. And we also digitize legacy data. So organizations spend a lot of resources in converting physical documents to digital files. So we are constantly increasing our digital data. And we store this data on devices, hard drives, and on the cloud. So what we see now is we are increasing our opportunities for digital data, and that is also being facilitated because of reduced costs of storage. And this is where big data starts becoming important. So we are looking at a situation where we are generating enormous opportunities out of large volumes of data that we generate, we collect, and so on. So typically, there are lots of different types of big data, but essentially what it really means is that we are generating more data than what we can process. So one of the ways to look at big data is this graph in the bottom. This graph was created sometime around 2015. And at that point of time, they were looking at the kind of data that was being generated. And they were trying to forecast what kind of data will be generated 5 years from then. So in 2015, they were saying that they are generating a lot of data, but the data would be massively going to increase. And now we are beyond 2020, so we have crossed that time, and we have actually seen the data being generated and the huge amounts of data that's being collected, recorded, and stored. So a nice way to look at this would also be to just think of the different ways we are collecting the data. So we have enterprise data. So the more startups we see, the more data intensive companies are coming up. So as a result, we are generating a lot more data. We have seen that social media has become really important for us. It's become very relevant, and most of us are spending a lot of time on Facebook, Twitter, Instagram, and so on. Recently, we have also observed a huge interest in physical devices and sensors. So for home automation, for example, or security applications, we see a lot of sensors and devices being installed, and all of that collects data. And due to the pandemic, a lot of our conversations have shifted online. So we see a lot more VoIP data than what might have been predicted in 2015. So this is just to say that the data we are encountering now is a lot more than what we would have thought just a few years back. So big data is this condition where we get a lot of data coming in. But big data is challenging. It's not as simple as just running a query and getting a response. But big data is unstructured. We often apply analytics on top of big data, and that brings some level of structure in there. And using that structure, we arrive at decisions. So over the last decade, we have developed a lot of automated tools for processing, analysis, and prediction. And these tools are things like data mining tools, big data analytics, natural language processing, AI, machine learning, and so on. So there are lots of different domains where our different fields where we have progressed a lot. And at the same time, we have defined this role called data scientist. And the role of the data scientist is really to derive actionable intelligence from high volumes of data, essentially big data. So you might ask, what does a data scientist do? And you might come across these memes where people think that data scientists do different types of things. And the data scientist might be thinking that my friends think I do some really intensive things, what our families think, what society thinks, and what I actually do. But these are kind of funny takes on what a data scientist does. And to some extent, all of these views hold true. You might actually be spending quite a lot of time writing programs, writing SQL queries, or you might spend quite a lot of time doing modeling. And often you spend a lot of time just shaping the data, just making it look like what you feel it should be looking like. So there are lots of different activities that you as a data scientist would be engaged in, and it is kind of a holistic process, the data science process. So really, if you aren't into the data science much, it might be a good starting point to read this article called 50 Years of Data Science. And the argument of this article is that data science has existed for many, many years. And it's not only the last 5 years that data scientist has become relevant. It has been in different shapes and in different forms, but data science is something that we have been doing for many years. And in this article, they define data scientists as a professional who uses scientific methods to liberate and create meaning from raw data. So if you look at the UK government's guidance on what a data scientist is, they specify quite clearly that data science involves knowledge and understanding of applied mathematics, statistics, and scientific practices, data engineering, manipulation, data science innovation, domain expertise, programming, understanding analysis across product life cycles, and so on. So it's not just about writing programs and analyzing the data, but it's also about this wider application of data analysis, of data science in real life contexts and in different application scenarios. Now, when we talk about data science, we often talk about the fact that we have to deal with a large volume of data and big data. So it might be a good idea to think of the data science world as what happened with the big data world. Because big data is still very relevant, and one might also argue that big data is shaped into the data science field. So Gartner comes up with this hype cycle every year, and Gartner is a global research and advisory firm, and they periodically review what kind of emerging technologies are being adopted, and they map them into different cycles. So the way you read the Gartner's hype cycle is by looking at these five different phases. So when a new technology comes in, that's what we call as innovation trigger. It then is proposed to be solving all of the world's problems. So that's where we go into an expectation hype. So that's where we reach the peak of inflated expectations. So everyone thinks that this is going to solve all the problems. And then at some point, people really realize that it's not as simple as that. So there are lots of different aspects to consider. And then there is a trough of disillusionment. So that's when people start losing faith in the technology. And slowly people start operationalizing the technology. So that's why it's called the slope of enlightenment. So people start adapting these technologies in different contexts. People know more about the new technology. And at some point, it reaches the plateau of productivity. So it's a really nice way of looking at emerging technology. And what Gartner did was it picked up on big data as being something quite relevant from around July 2012. I think even 2011, big data was in one place in the hype cycle. So anyway, so big data was picked up as one of the key technologies to keep our interest on. So what does the hype cycle look like now? So on the left, you see big data coming up in 2011, and then 2012, then 2013. 2014, it went through the trough of disillusionment, and then at some point, it just disappeared from Gartner's hype cycle. So now if we look at the hype cycle, this is 2020, July 2020, we don't see big data at all in Gartner's hype cycle. But what we see are aspects of big data and things that we were talking about back in 2012, 2013. And we see them coming up as different topics. And topics like explainable AI, ontologies and graphs, embedded AI, and all of these things are starting to come up now. And these are in different stages of the hype cycle. But what it shows is that big data came up as a topic which initiated a lot of different fields in data science. And what data science tries to do is to bring together a lot of these different fields into practice. And in many cases, we have seen this being applied quite well. So Gartner's Hype Cycle provides a good indication of where we are heading. And from our experience, from our observations, we can confirm several of these trends. So big data is not a solved problem, but a considerable amount of effort has helped solve some of the challenges. But new problems have started to emerge. And that's why we see things like the AI topics like explainable AI or understandable AI. So I'd like to talk about three interesting trends in data science that are quite relevant at this point of time. So the first trend is edge processing. From many years back, from decades back, the interest was in creating machines or creating computer systems which are high-end, which increase their processing capability year on year. So we see that there has been a lot of investment in creating desktops or creating servers which are fast. But now there is an interest in creating edge processing technologies, better, faster, more dynamic processing, in-memory processing, mobile processing becoming more and more relevant. And that's because we are getting smartphones and we want to do a lot of interesting computation within our smartphones. So we see things like the Apple's M1 chip coming up, and they are talking about doing machine learning in a mobile system or doing machine learning in a small device. So edge processing becomes more and more interesting, and that makes new methods of sensing more and more interesting. It also makes new products more applicable. So, for example, you can have mobile apps where they do in-memory processing to do image recognition, to do object recognition quick enough so to help specific aspects, like if you are in a street and you see something happening, you can click a picture, or you can just put the viewfinder, the mobile viewfinder, on the scene, and it immediately tells you that if it's a high risk area or so on, or if there's a fire or something like that. It can also help you design more interesting apps where you can do automated image annotations on mobiles. The next thing that I'd like to talk about is the need for more relationships. So we have developed tools like natural language processing tools, but what the interest now is on understanding and embedding relationships in text data. So we see a lot of applications of graph processing and graph analysis in NLP, and also in tools that use NLP systems. So for example, earlier on the left, you see an image of how Google search would look like. You would just search for a topic or for a keyword, and you would get a list of pages that are relevant to the keyword. But now you see more things coming up. So the context window on the right shows not just about the Taj Mahal, but also about who built the Taj Mahal, how tall it is, where is it located, what are the other things that people search for. So it's this relationships which are becoming more and more important, more and more relevant. So for us to use technologies, to use new services that we hadn't thought would be possible earlier. Now, the other interest in data science, and this is becoming more and more of a trend, is to understand social context better. So we've seen the impact of data science, we've seen the impact of AI, and we've seen how that can be used to manipulate public opinion. We have seen how ethical aspects are being questioned. So we have seen new branches of research coming up on privacy, security, ethics, legal aspects of data science. We have heard about the Cambridge Analytica scandal. We come across more and more of these scandals. There is a huge question around bias, transparency, and explainable AI. So for example, what kind of data is being used for training our AI systems? So when we search for data, we see biases. So image searches for doctors used to highlight hidden biases, like you would only get white doctors from Western countries being shown as image searches. So there is a huge question around bias and transparency in AI. We also see that AI, data science, social media has become more part of our lives. So we come across online social movements, hashtag activism, which doesn't just stay in the virtual world, but it becomes part of our physical world. So ALS Ice Bucket Challenge, Black Lives Matter, Arab Spring, Me Too, all of these movements have not just stayed in the social media world, but it has impacted our lives and how we engage with our environment. So there is an increased recognition of the data science for social and cultural applications as well. The other trend that has resulted from all of this is that data science is now looked at as an interface between data scientists and business government executives. And we are also looking at more and more applications of data science for non-data scientists. So if I'm not an expert in data science, if I'm not a programmer, I should still be able to use data science methods. I should still be able to create data science experiments. So I can use plugins, modules, and libraries which are available open source, and I can easily integrate them across platform, cloud, mobile systems, and so on. So data science is becoming more and more for the non-data scientists or non-computer scientists. So all of this leads on, and especially the last aspect of the social context in data science, leads on to an aspect that we are quite familiar with, which is called smart cities, and then further leads on to the Urbanmapper project. So I'll give a quick introduction to smart cities and the social aspects of smart cities first. So what we look at in smart cities and what we're looking at now, wherever we are, around 50% of the global population lives in metropolitan areas. And this is likely to grow to 75% by 2050, if not earlier. So we are going to look at situations where cities are becoming more and more dense, more and more populated, and there is already a mismatch between supply and demand. And this is a consequence of growing, and we cannot help that will happen. So cities and metropolitan areas are characterized by dense urban cores and a slightly less populated surrounding regions. So cities are getting bigger, but are also becoming constantly strained. So services will need to be provided to people who need help. Resources will need to be dedicated for everyone. So there is going to be more and more strains in this system. So smart cities came up as a result of this need, where traditional approaches toward managing cities is becoming increasingly unscalable, increasing population and pressures on resources and services, and the need for more efficient services. We need to understand the impact of our changing environment more. We know that we are going through climate change. We know that this is going to be impacting us. So we need to understand better how it is impacting us now. We need to improve technical abilities in sensor technologies, mobile phones, connectivity, computation, and so on. And smart cities are trying to make use of data-driven, evidence-based approaches towards decision making. So that's kind of led to this whole view of smart cities and how smart cities can help address some of these problems we are currently encountering and we are likely to encounter in the future. So what smart cities try to do is to look at different aspects of the cities. For example, infrastructure, the built environment, the service industry, industries in general, the natural environment, and try to sense different parameters of these aspects. So in terms of infrastructure, sensing how the infrastructure is being used, how they are performing, how the roads are performing, what status the roads are in, for example. The built environment looks at how the new redevelopment initiatives are serving the communities. They are also looking at how new buildings are being used and so on. The natural environment, you tend to sense the weather, you tend to sense the environmental aspects of different fields, of different parks and so on. So all of these try to, what smart cities try to do is to try to understand by sensing aspects of these different components of smart cities and use the data to deliver better services, to deliver better interventions within the communities. And the idea is that all of this will holistically help in providing better services. So what is a smart city? And there are lots of different definitions. For example, IBM's definition comes up with interconnected information, understand controlling operations, optimize the use of resources, and so on. Cisco, Manchester Digital Agency, and all of these kind of are like an utopian vision of connected devices, smart homes, IoT, smart cars, and so on. And the question is this a technocratic solution to a socio-technical problem? Smart cities are about people, cities are about people. So often we come across this image, which is where the urban planners, where city developers have designed the city in some way, but the user experience is something which requires something completely different. So this image kind of shows that sometimes people want something slightly different. So it's useful to recognize what users and communities are asking for. And there are lots of really interesting ways of how you can do this in a creative way. You can do this in a really playful manner, and so on. So there are lots of really nice ideas which we come across when we look at urban environments and how people have used different ways of impacting their environments. So smart city is not only about the information, the data, but it's also about the user experience, the citizen's experience. But you might already say that we already have smart cities, and it's not something that's just come up in the last 2 years. In fact, you're right in thinking that, and for a while we have had smart cities, and a lot of these ideas started emerging from the 70s or 80s. And there are very different definitions of smart cities in different contexts, and they are serving different local needs. And if you look at Smart City Index, they very nicely, they look at different parameters. They look at a lot of the cities which are smart cities and try to rank them. So it's another way of looking at smart cities. But it's difficult to understand exactly how many smart cities are there or are being developed. And there is a really interesting study by Jaws, 2019, who studied mentions of around 5,500 cities. And what they did was they looked at hit counts of co-occurring with smart cities. So they looked at all of the cities which had over 100,000 residents, and then they did a search in a search engine, and they added smart city to the city name. So using that, they did a bit of processing, and they identified 27 cities, and they looked at the top 20 hits of the responses from the search engine. And what they found was that the really strong cities, the cities that came up quite a lot, had a strong globalizing narrative. So it's not just about the technology, but it's also about the people who come to the cities, the people who are relevant to the cities, who have this global aspect in the cities. And they also found that the city's agenda was more about transformative governance rather than just incremental systems and processes. So it's not just about adding 3 sensors in a city, but it's also about how you transform the governance in a city that might impact how a city becomes a smart city. And a really nice example while talking about smart cities is the Sidewalk Toronto project. If you are aware of this Sidewalk Toronto project, you will probably know what we are talking about, but essentially this was something like the Google Smart City vision. So it started with a small area in Toronto, and so developers identified this region and they wanted to transform this. So they wanted to kind of change how this area is and how it can serve the citizens. So they came up with, so Google came up with this really interesting vision of taking this area and creating really interesting spaces and for pedestrian areas using sustainable buildings. They had ideas about pavements with embedded lights and embedded heating because the area can get really cold in the winter. They also had some ideas like outdoor comfort ideas, and they came up with some radical ideas like raincoats on buildings and so on. They also had things like underground delivery systems of logistic systems and so on. So what happened to the Sidewalk Toronto project? So it was initiated in 2017. Alphabet, which is Google's parent company, won the bid. The plan was developed via consultation with over 21,000 members of the public. However, in May 2020, the plan was cancelled. The idea was dropped. And there are several reasons for that. They stated that the pandemic had a huge impact on that. But there was also other factors, like one of the most important factors that we can talk about now is the lack of trust. Google is an American company which was collecting data from residents and visitors about a region in Canada. So there were questions about who controls it, how good would the anonymization be, and so on. And there was also resistance to intrusive technology. So, for example, the idea of using face recognition for street cameras is quite scary for people. The idea of understanding the occupancy of different homes is difficult to get beyond acceptance. The idea of having 5G connections, 5G already had kind of lots of talking points around that time. So there were lots of technologies that were being proposed, and people started resisting these technologies. So anyway, the project, which was really interesting, that got cancelled. So it kind of shows that communities do matter, even though Google's Sidewalk project was considering the views of 21,000 residents. It also shows that these views might change. There may be other people who might need to be brought into the decision-making processes and so on. So the communities matter because the essence of cities are in their citizens and communities. So eventually, cities aren't where technology will be stored. They are places where people will live. And often there are conflicting interests on resource-related decisions, and there are multiple stakeholders. So it's not just citizens, it's also different types of communities living in the area. It's also understanding environmental aspects, the political aspects, economic aspects, and so many other aspects that need to be considered. And so far, we've had a passive role of communities in this area. And the rising impact of climate change. So we often hear about huge hurricanes, huge cyclones coming in, destroying local areas. But we also often don't get to hear about small changes that's happening in our neighborhoods, in our backyards, that we might be able to get some sense of. So sometimes it's useful to hear from citizens what are the small changes that are happening. For example, this year the birds have come late, or this year the flowers are blooming slightly early. So all of these things might help us understand better how our environments are changing. And services are constantly challenged. So the impact of climate change is also something that is something we need to consider. So urban planning is an area which is concerned with the social, economic, environmental consequences of boundaries, and this area tries to influence the spatial distributions of resources. So as a result, in smart cities, urban planning is a domain which is really important, which is one of the primary areas that are concerned with smart cities. So in the UK specifically, urban planning is a complex process. It is often cyclic and it involves multiple iterations. It's important to understand why urban planning came into place. So in the industrial times, when cities were becoming larger, more and more people were moving into cities because of factories, because of industries. Cities were becoming unscalable. So there was a need for something which is a lot more robust, which is systematic, to come into place and influence how cities are going to be built and how areas can be redeveloped, regenerated, and so on. So this process of urban planning arises from a specific need that is identified by citizens, communities, local authorities, or businesses in the form of a physical intervention in urban space. And a physical intervention could be creation of a new, say, railway station, or the redevelopment of a disused area, or regeneration of a brownfield site, and so on. So there are different ways of how urban planning, of how physical interventions can be made in urban planning. And there are different types of planning. There are strategic planning, land use, redevelopment, regeneration, and so on. It is a complex exercise, and it happens in a variety of scales. So there are small projects in urban planning which only relate to a small shop that's going to be changed into, say, a retail unit or something like that. But there are large developments as well, which might be taking an entire disused space, a huge parking lot, and converting that to a shopping mall, and so on. And it involves the preparation of development proposals. So the urban planning process involves in creating these proposals. They are created by either consultants or individuals. The proposals are submitted, and they are considered by local authorities and by planning experts. And then a decision is taken on those proposals, and based on the decisions, the urban planning process allows for the creation of these new spaces. So a lot of a variety of perspectives are taken into consideration, and stakeholders are also taken into consideration in this process. And an aspect of urban planning, so whenever we create these proposals, we also expect an impact assessment to be created. So before you create a proposal for a new railway station or a new shopping mall and so on, you're expected to create an impact assessment. And the impact assessment will involve quantitative expectations of what the development will achieve. So you would need to provide some detailed ideas about how many new jobs will be created, how much more footfall will be increased or reduced, how much green space will you be adding when you've kind of created this project, and so on. How much open space will be increased, and so on. So these are very quantitative estimates of what the development will achieve. So the Urbanmapper project is interested in looking at this impact assessment of urban planning. So it's a 2-year project on understanding how outcomes of urban planning can be assessed. So the question is, when we look at these impact assessments, a majority of the assessments are quantitative. They are about how the health will improve, so how many fewer patients will be admitted into the hospitals, or how many new jobs will be created, and so on. But what's largely missing in urban planning is to ask the more qualitative questions or the more social questions of urban planning projects. So when you create a new development, how have people's lives changed? Or asking questions about how does the development impact on the sense of belonging, or how does the development impact on the community spirit of that neighborhood. And this is a complex task and often requires understanding multiple perspectives. So understanding mental health, well-being, transport, economy, environment, and so on. So that's why it's quite complex. And the Urbanmapper project is a project which is coming to its conclusions, but we have some ideas on how to take it forward as well. So the project aims to create a set of indicators based on literature reviews, policy reviews, impact assessments, and so on. And we are aiming to, we've created an ontology of urban planning outcomes, and we try to understand how we feel when we live in a place. So this is not just about understanding how many new people have joined a community. It's about understanding how we feel when we live in a place. So what we did in the project was to look at around 400 indicators from literature review. And we created this very large graph. And in the graph, you see what you see are each of these small dots are a topic. And the topics are something like visible characteristics of something, presence of a particular aspect. And we also found quite a lot of counts. So when you come across understanding how we feel about a place, we might want to look at physical characteristics of a place. So does the place look like it is well maintained? Or does the place look like there is a lot of rubbish in the road? Or do the houses look like they are well maintained, and so on? So we came up with these kind of 400 indicators, and we created an ontology, and we have different characteristics that we can look at. And some of the aspects that we look at are things like how many pedestrian signals that we can see. Can we look at parking spaces? What kind of urban furniture is visible in the road, and so on. So there's quite a few things that we think in the project that can help us understand how we might be feeling when we are in a neighborhood. So what we like to think of this as a holistic approach to sensing smart cities. So it's not just about sensing some aspects of infrastructure or service, industry, built environment, and so on, but it's also understanding how citizens and communities feel when they are in a smart city. So the Urbanmapper project looks at how we can understand using crowdsourcing citizen science techniques to sense the local environments. So we have a bit of an activity that I would like you to think of. So this is about 2 minutes that we can give for this activity. So the question is, imagine any neighborhood. It could be your home, your workplace, your university, your friend's place, whatever it is. You are a resident in this neighborhood, and a large derelict building will be converted into office spaces or recreational center and retail units. And you are interested in understanding how this new development will impact your community. So can you think of a way we can understand or study this impact in your community? So the question is, we have a huge building like this, and we want to convert that into office or retail space, and we want to understand how we can perceive what the community would feel about it. So what kind of methods if you were to design a research project, how would you seek some ideas from the community? Now, if you click on the link on top, or if you just type out the link, if you have a QR code reader, you can also scan that. You will be directed to a web page, and over there you can.
I have posted the link in the chat box also, sir.
Oh, that's great. Thank you, Dr. Deepa. That's really helpful. So you will surely have the link to the website. So if you click on that link, you will be able to add something to that. So there's a plus button. So when you click on the plus button, you can just add some ideas. So if you would see that I've already come up with one idea, and hopefully you would realize that that might not be a great idea, and hopefully you would come up with some other ideas. So let's think for about 2 minutes, and then we will see some of the answers that you might have come across. So we'll pause here for 2 minutes, and then we'll continue with the rest of the webinar.
So I do request the participants to click on the link and do the activity as requested by Dr. Suvodeep sir. A few feedback forms and will also be shared right now. I request all the participants to fill that also before the end of the session. We do provide the certificates, but it is required that the feedback forms need to be filled by all the participants in order to provide the certificates for participating in this webinar. Thank you.
Okay, I think we can get back into the webinar. So I've looked at very quickly on one comment which came in. So I didn't see anything more. But one comment was, we came so far from ancient civilizations to modern and still looking for flying cars. Yeah, I think that is how we are by nature. We are probably explorers, so we want to discover more and invent more and change our environments more. So, well, anyway, if you do have any ideas, please do drop in. It'd be nice to see some of your ideas on how you can research this problem. But let's move on. So in the Urban Mapper project, we are thinking of some ideas. One of the approach is to explore crowdsourcing. And what we are thinking is we could offer the general public an access to a link where they can do a digital walkthrough of neighborhoods. And it could be through a series of images, or it could be through something like Google Street View. And ask them questions which are quite qualitative in nature. So ask them questions like, what aspects of this neighborhood appeals to you? Or what is your perceived aesthetic value of this neighborhood or street? Or how do you feel about the sense of belonging in an area? Now, of course, this is something which would be there before a new project was created, but it would also help us understand what people find valuable when they are looking at an urban environment. So that's one of the ideas. And another idea that we are thinking of is to look at automated approaches to analyze open data sets. So we could look at free data sets and imagery to understand what techniques, so for example, deep learning, can be used to estimate indicators of outcomes. So among these 400 things or 400 indicators, what are the things that we can automatically analyze? So we could do object recognition, scene analysis, and we could pick up on things like pedestrian signals or urban furniture, bicycle racks, and things like that. And some of them could be used to develop a broader sense of how a neighborhood is, or what it is to be living in that neighborhood. And then we could align that with some qualitative perception of areas. So the question where we can ask members of the public about what do they perceive about about these neighborhoods, we can then map that to automated image analysis and object recognition. So this is something that we are going to be doing in the next few months. So hopefully, if we do have a conversation later on, and you can ask me later on how that went, I might be able to give you some answers on how the project concluded eventually. So I wanted to do a quick recap. So the recap started from where we are looking at the trends in data science. So we talked about the trend where we are looking at more power, more edge processing, in-memory mobile processing. And we also looked at the trend where we are trying to understand more relationships. And then the other trend was to understand social context. And it's important for us to note that these are not the only trends in data science. Data science is a huge topic, but these are the topics that I thought would be interesting in picking up on in this webinar. We can probably have a whole course on what are the new things in data science, and we wouldn't finish the course. It would be so huge. So anyway, the final thing that was the social context, and understanding that data science is not just about algorithms and creating new computational programs or so on, but it's also about application of data science in different contexts and understanding the implications of data science in these contexts. Now, the other thing we didn't talk much about is the data science process itself and how the role of data scientist is evolving. So typically, if you look at an organization, you would have a data layer. So you would have different databases belonging to different projects, different business units, and so on. You would have some data in the form of raw text files. You would have some in PDF. You would have documents, but you would have also data from the cloud and so on. So in an organization, you would have a data layer. you would also have a set of data scientists. So the data scientists will, so for example, over here, we have 3 data scientists who are working in a data science team, and they would write scripts, they would write queries, they would create reports, they would process the data, and so on. So these are the data scientist layer. And the data scientists would be talking to senior management, to stakeholders, clients, partners, and so on. And they would be collecting requirements. They would be understanding the business and social context of the data science activities. They would conduct analyses, design experiments. They would also explain their findings, redesign experiments, and so on. So it turns out that this is a huge responsibility. It has a lot of tasks. So the data scientist does not only have to write scripts, queries, programs to process the data, report generation, and so on, but they also have to talk to senior management, stakeholders, understand what they need, understand what they need to provide, balance the expectations, and so on. So there's quite a lot of tasks for the data scientist. So this started becoming a problem because a data scientist cannot do so much. So what we see is the role of data scientist is evolving as well. And we see a new type of data scientist being in demand in the industry, and that's called the type 2 data scientist. Now, the type 2 data scientists sit above the type 1 data scientists. So the previous data scientists that we talked about became more of a type 1 data scientist, and type 2 data scientists became closer to the stakeholders and senior management. So now we see the role of data scientists being slightly split. One role becoming type 1, which is more about the data processing, the data analysis, the machine learning aspects. And we see the type 2 data scientist, which is more about understanding the context of use of data science, the context of application of data science, understanding the other implications of how data science is impacting an organization, and so on. And they are closer to senior management. And typically type 2 data scientists lead a team of type 1 data scientists. Now, if you look at this, this link down below, they kind of describe what the type 1 and type 2 data scientists do. So type 2 data scientists will typically understand the activities involved in the broader data life cycle, such as data generation and so on, adding metadata, data storage, and they would have expertise in doing things like the communication, storyteller, domain knowledge, technical solutions, coming up with new ideas, business focused, so they are closer to the business, whereas type 1 data scientists would be having more of a day-to-day role in doing things like statistics, data mining, and so on. So there's a slight difference in data science and data analytics. So one of the things you might ask is that data science has a science term in there. So one of the aspects of this is because data science is not just about finding an answer, but also it's not just about doing analysis of the data, but it's also understanding the context of the analysis of the data. It's understanding who is going to do the analysis, understanding who is going to be using the analysis, and so on. So there is a scientific process to doing that, and the data science kind of leads towards that area. Some other differences might exist, although sometimes these terms are used interchangeably. Sometimes data scientists do more of the prediction, whereas data analytics do more of the analysis of trends. So what's happening now, whereas the data science might be doing what's going to happen 5 or 10 years from now. Type 1 data scientists are typically the data analytics people. So type 1 data scientists are closer to the data, and therefore they do more of the hardcore data analytics. Whereas type 2 data scientists are kind of people who lead towards data science. There's also the understanding of technical, social perspectives, and more of a holistic process when you are looking at data science. So when you're looking at data science, you look at the entire process of the data science. So what I'd like to talk a bit about is our vision of data science. So in the information school, we have an interdisciplinary research, as I mentioned earlier, and we are quite well established. We were founded in 1963 as postgraduate school of librarianship. So, and in the research groups, you see that we have quite a lot of expertise in different areas. So today, the information school is currently around 33 academics, over 60 research staff and PhD students. We are the first in the world for library and information management based on QS World University rankings by subject. And we have a vision for data science in the University of Sheffield. And our data science course, which is the MSc Data Science course, we look at 1 year full-time course, and we are accredited by the CILIP, which is Chartered Institute for Library and Information Professionals, and we aim for type 2 data scientists. So we aim to create type 2 data scientists, where it's not just about the programs or just about the AI approaches or machine learning modules, but it's also about how it's being applied, what are the societal considerations that we need to make when we look at data science. Typically, we target graduate students with good honors degree for the MSc Data Science course. We do say that work experience is not essential, but prior knowledge of statistics or data analysis is required. And English language competence is also required for our course. We have our graduates in lots of different organizations, and the list is quite long, so I just mentioned some of them. PlusNet, Cancer Research UK, Intel, Jet2, Peak Indicators. We have lots of companies who recruit our graduates. And a bit around the societal and business context. So in the MSc Data Science program, we have modules which are very close to the data. So these are things which are like the type 1 data scientist modules, like data understanding, data preparation, modeling, evaluation, and so on. We have the business context modules as well, and we have some social context modules. For example, the data and society module is a module where we look at the context of application of data science, AI in the society, what are the ethical, legal implications of doing so, and so on. So we have lots of different types of modules where we try to build in this MSc Data Science or the data scientist role quite a lot. And we also have other courses like MSc Information Management, Information Systems Management, Librarianship, Library and Information Systems Management, and so on. So what I'd really suggest, if you are interested, do look into our courses. There's a link below. And these are courses mainly for, so the other courses are mainly for non-data scientist type of areas. But yeah, if you are interested, please do feel free to get in touch. Ask us any questions you are interested in. And I think we are done for now for this webinar, but I'm happy to hear any questions that you might have. So thank you for listening. And if you have any doubts, please do reach out. If you have doubts and you come up with a doubt later on, please do get in touch. I'll be very happy to hear from you. And I'll also check out that that link if there are any more ideas you might have thought of. So I'd like to thank you very much for coming to this session and for listening. And any questions, please ask. I think we are here for the next few minutes, so I'm happy to answer questions. So I leave it to you, Dr. Deepa, and you can take over now.
Yes, yes. So if any of the participants have any queries or questions, you can post it in the chat box.
I see one question. I'm just going up through the list of the questions. I see one question by Aarti. and the question was about the ontological profiles. So this was basically what we did in the project, was to create an ontology, and the ontology had about it had quite a few concepts, and we were looking at just load it up. Yeah, so we took the 400 indicators and we grouped them based on themes. So some of the indicators were about the local environment. Some of them were about just the physical characteristics of neighborhoods and so on. So as a result, what we came up with were a set of themes, and the themes were aligned with things like qualitative characteristics. So the aesthetic value of a place, things like comfort of being in a place, or how confident you are in being in the place, or do the neighbors have a positive attitude. So we kind of broke them down into these different components. But we also had other components like the physical space or the economic aspects of the area and so on. But if you are interested, I can find a link to the ontology. It is a very rough form, so it wouldn't be much helpful. But I have the ontology that I can share, and I'll put on the link over here after this session. Okay, I'm looking at any other questions. I do see that quite a few of you have responded that you find the session useful, so that's very helpful. Thank you for sharing that. But if you have any other questions, please do feel free to ask.
I think we can, the participants are very happy with the session, and they have given their feedback. I hope you're going through the messages posted by the participants. Yes. Yes,
that's great. Yes, thank you for sharing your views on the session. And if you have any doubts, do feel free to reach out.
And over to Doreen, our student from Department of Electronics and Communication, to deliver the vote of thanks.
Plenty of food for thought. Thank you, sir, for your valuable insights. It was indeed an insightful session delivered by Dr. Suvodeep Mazumdar. I'm sure that this session would have cleared the clouds in our mind about trends in data science and Urbanmapper, and widen the horizons to explore new arenas. Once again, on behalf of the KCG fraternity, thank you, sir, for this session. Heartfelt thanks goes out to our faculties and the organization who always stand by us, guide us, lead us, and motivate us. And a special thanks to all the participants, students, and faculties who has shown interest in this session and made it a successful one. I would like to invite Dr. Deepa Jose to deliver the vote of thanks.
On behalf of the entire faculty team of KCG College of Technology, I would express my sincere, heartfelt gratitude to Dr. Suvodeep sir for accepting the request, even though this is a vacation time for sir. Sir had readily accepted our request. And I hope that this session will be a starter for future collaborations between our college and the University of Sheffield, as far as research as well as higher studies is concerned. So your session was very insightful, and you had discussed on the various factors to be considered for a systematic and robust planning of smart cities, which in fact I understand from your session is that it's a very big research exercise which cannot be discussed in just 1 hour time. But you had given a very clear overview of the entire aspect. And on behalf of the participants, once again, I thank you, sir, and I hope to meet you online for many future sessions. Thank you once again.
Thank you, Dr. Deepa. It's been very helpful. It was a really nice session, and I really enjoyed reading the comments. And thank you for having me here. It's been great. I hope we do get to collaborate in the future, and we do get to continue our conversations beyond this session. So please do feel free to get in touch, and I'm sure we will be in touch in the future. So it was a great session and very well managed as well. So thank you, Dr. Deepa, and thank you, Doreen. It was great to be here. Thank you.
Thank you, sir.